Hello, this is the second part of the design for the punching bag support. In this video, I'm going to analyze the spring of the locked system. The idea is stop the rotation when the support is in use. Uh, we can push this bar down to unlock the bracket. So let's go to see how to make the calculation of the force reaction when we unlock the bar. Um, we can make this evaluation using the spring equations. From the Hooke's law, we get the spring equation and R. This is the spring ratio equation that represent the stiffness given for the geometry and the mechanical properties from the material, Young's modulus. Um, in this case, we need to calculate first the spring rate equation. For this, we need to get the shared modulus of the spring of the material. We can obtain this equation from the Young's model equation, and here is the equation. The second parameter needed is the wire size. We also need the diameter of the coil and the number of turns we'll get the wire. Uh, for this case, I get the geometry from the key creator. This is a spring tool that I use in specific in the software, and it's very easily. It's just to put these parameters here, and the software will create the geometry in this case in solid. Okay, and I already solved the equation in Wolfram Alpha. The spring rate is 2.37 Newton millimeters. The next step is obtain the force. To obtain the force, we multiply the spring ratio for the spring deflection. In this case, is how much we're going to displace the bar, and the value is 13 millimeters. So the for reaction is 30 newtons. Um, so let's go to the simulation. We are going to check how close we are of this number. Mm, for this analysis, I'm using nonlinear contacts and linear contacts. I'm using, of course, linear contacts to define these parts that will be welding parts, and also this linear contact to between the bar and this. I was thinking to use a screw. Um, in this case, the restriction is or the contact is between the bar and the screw. We also get this contact between these small faces and the screw. And I'm using a frictional contact between the bracket and the spring, only in the region that it will be in touch. So we can see this solution. This is the convergence for Newton-Raphson graphic, and also we can see the total deformation here. Let's put it in for seconds and see how is the deformation. Oh, okay. One of the boundary condition is, of course, I was omitting, is the fixed support that it will be in this screw slots, and the displacement. In this case, I'm applying a displacement in the bar. Um, Finally, we can obtain the force reaction. Um, the displacement is uh, applied here, and the force reaction is 35 newtons. So we are very close, but there is something that we need to consider, that in this case, the last coil is not in use. We are only using around 9 or 8.5 coils. So this is something that could be an influence in direction. The direction is higher, and also the frictional coefficient in the system will increase the reaction. But we are very close. I consider that 35, 30 newtons is enough. And there is one more step for this design. I'm going to add cylinder here. In case that we, for example, uh, exceed this displacement, we are not lose the bar. This is the idea. Or also we can apply, we can create another restriction here, for example, to uh, um, restrict the displacement. Something that we can do. But yes, in general, this is the idea. This is how we analyze. In this case, the parameters that we can move is the number of coils and the number, also the thickness of the spring, the thickness of the wire. If we increase these parameters, we are going to increase the stiffness and the reaction will be higher. Okay, I hope enjoyed this video. Thank you for watching me, and I see you the next time. Bye.